Hi guys, welcome to my channel. In this video, we are going to discuss about one of the design pattern in the microservice. In the last video, we discussed about the service registry. The service registry we discussed in the three videos. In first video, we discussed about the service registry. Second video, we discussed about the client side service discovery. On third video, we discussed about the server side service discovery pattern. So this is the new design pattern. Now we are going to discuss. This is the database per service pattern. So before discussing this database per service pattern, let's assume you have a e-commerce application. Like this is going to be one e-commerce application which is developed in the pattern of the monolithic pattern. Okay, so if you develop any application in point of the monolithic, then everything will be in a single unit, right? So if you are thinking about this is a e-commerce application, okay, like you are going to store the users info, you are going to store the users info, and you need to maintain the product info, and you have to maintain the payment. So someone need to make the payment, right? So payment flow, like this many many of the information is going to be handled in a single unit. Okay, single unit, everything will be maintained in a single unit. This is a monolithic application. So it is a simple monolithic application which is developed for one of the e-commerce website. Okay, this is a old pattern, monolithic one. So now if you are using this pattern, now you go definitely we require the database, right? So this is going to be our database. So this is the database. This may be anything, Oracle or Postgres, anyone we can use it. So this entire application is going to connect the this database only. Entire application is going to connect this application only. Okay, so here whatever the users information we are going to store here only, product information we are going to store in this database only, payment flow related information, like if you needed to maintain any some master information regarding the payment or everything, it is going to store in the single database. This is the single database, everything we are going to store here only. So this is the usually we are following the uh, monolithic application pattern. But now, what is the disadvantage of using this pattern? So definitely there is a disadvantage. Why? Because so let's say an example. So if you are storing all the information in the single database, that means we are face the slowness issue. The second one is maybe if users product info or payment flow, any one of these service you want to scale. So if you want to scale this one, entire database need to be scaled. Only product info or payment or users info, we cannot scale. Why? Because it is a combined single unit. That's why if you want to scale, definitely you need to scale entire application. I mean entire database. That will create the problem. So to eliminate this problem, okay, we have so many issues. Okay, not only these two things, we have too many issues. Okay, like let's say an example, I want to store this user information in some different database and product info some different database. That is not possible, right? Everything is linked with the single database. That's why it is a constraint. You cannot go with multiple databases. You should stick with the only one type of the database for the all this type of operations. So these many issues we have. At the same time, we have some advantages also. We will discuss those points at the end of this video. For now, you understand. So if it is a normal monolithic application, the application is going to connect with the single database. But it is a not suggestible way if you are working with the, so let's say if you are working with any organization, definitely it is not going to be suggestible thing. Okay, you need to follow the design pattern called database per each service. That means you have to maintain each database for each service. Okay, Now, whatever we discuss, same thing we are going to discuss in the database per service pattern. Okay. Now, let's assume you have the three services. Now, let's read this definition. Okay. The database per service pattern is a design used in the microservice. Okay, what is the design? Where each service that has its own database. That means whatever the service, like now, if you take an example of the e-commerce site, you are going to have the user service, product service, order service, inventory service. Okay, these three services we are going to develop like a three or four Spring Boot applications. These four Spring Boot applications is going to connect with their own database. Okay, user service is going to connect with their own database, product service is going to connect with their own database. They won't depends on each other. Okay, this means each service stores manage its own data without relying on other service database. Okay, that means if you maintain each separate database for the each service, that means everything will be independent. They won't worry about each other data. Okay, the service can work independently, yes, and no service can directly access data of the another service. Okay, if that means if service is going to be having a separate database, that means another service they cannot call directly to the other service data. So if they want to any data, they are going to use the REST calls to interact each other. Okay, so you will understand this definition. Okay, not immediately. Let's focus on the some practical how it is going to impact. Like I prepared one example. Okay, example, this is you have the e-commerce platform. Okay, if you have the e-commerce platform, first how many service we have as of now? User service, product service, order service, inventory service. Okay, let's make it right. Now I have the one service, and this is one service, and this is going to be another service, this is going to be another service, and I'm going to have one more service. Okay, then first one is the user service. This is the user service, and second one is the product service. This is going to be product service. Then next one is the order service. Then see, this is going to be order service. Then this is going to be inventory service. Now I have the four services. Now each service it is going to have their own database. Okay, each service they are going to have their own database. Okay, this is one database, this is one more database, this is one more database, and this is one more database. That means I have the four databases, I have the four services. Now let's think what is the user service will do. User service will store the only user information. You can see manage user accounts. That means so if you want to log in with you, if you want to log in the e-commerce platform, definitely you need to enter your username and password, right? The such type of information is going to taken care by the user service. Okay, now the database I'm going to use for the user maintenance is the Postgres. So this is a Postgres service. Now my user service is going to interact with this database. Okay, it is going to interact with this database. Then next one is the product service. What is the purpose of the product service? Here we have the product service. So what it will do, manage the product information. That means so in it is going to manage number of products, what are the products is available, and what is the price and description, product related information it is going to store. So for this purpose, based on our data, based on our data, okay, if it is user service, it is simply we can go with the PostgreSQL. Why? Because that is a structured database that is suitable to that one. Product service, based on our data, we can choose what type of the database is best suitable to maintain this kind of the information. In my case, I'm going to store the product service, it is going to maintain the product information. So if for maintaining the product type of data, MongoDB is the suitable one, non-SQL MongoDB. So that's why here I'm choosing the MongoDB. Okay. So here I'm choosing the my product service is going to interact with this MongoDB. Then next, order service. Order services manage the customer orders. Now I log into the application, I saw the products. Now I'm making the order. So once I order that one, the information need to store in somewhere, right? So that will taken care by the order service. So in this case, I'm going to use MySQL. Well, that is our wish. Either we can use the Postgres or we can use the MySQL. That is up to our choice. There is no restriction here. But if you go with the single database, definitely you cannot use the different type of the database. Why? Because every application is going to connect with the same database. Hmm? Okay, now in secondary inventory service, it is some kind of the Redis database log, something we can use, but just ignore this one. Now I'm using again the some other database like Oracle or something else. Okay, so this is also like you can assume this is also by Postgres SQL. Okay, this is also Postgres SQL. Now you can see user service is interacting with every service. Now I have the four services. Each service is going to connect with their respective database. Okay, there is no restriction in the database. Either user service can use the Postgres, product service can use the MongoDB, order service may use the MySQL. Like this, there is no restriction what type of database we are going to use it. So each service, it is going to maintain their own data. Okay, user service is only think about the user data, product service is only think about the product data, order service only think about the order service. That means everything be work independently. Okay, in some cases, okay, then order service want to interact with the product service or product service want to interact with order service, they need to exchange the data between the both of them. In this case, they directly order service directly won't interact with the database of the product service. Instead of that one, what it will do, it will make a call to the product service to via REST. Based on that, they are going to exchange the data. That by making by implementing this design pattern, what is the benefits? So now i'm I'm getting the multiple orders due to some festival season. That time I will only able to scale the order service instead of the worrying about the other services. The scaling is possible. Why? Because this service is running independently without affecting the other services. I can able to scale this one. At the same time, if I want to change this MySQL database to other database, then I can simply make the changes without affecting the other things. Like this many uh, advantages we have. Okay, let me go back one by one. So what are the advantages we have? Service autonomy. Service autonomy means each service, just now we discussed, right? Each service, it is going to run independently. Okay, each service is fully independent and can change its data model or database technology without affecting others. That means now if you go to the any other I mean now this is a product we are going to purchase this, right? Now maybe someone maybe prefer to use the PostgreSQL and someone maybe use the Oracle. Based on the customer requirement, we can simply change this one. So user service, it is a security related thing, right? User, we are going to store the passwords. That means mostly they will prefer to use the Oracle in this case. That means if I want to change this database from the Postgres to Oracle, I can simply change it without affecting this remaining all service. That means it is fully autonomy, without that is running independently. That's why we are able to do whatever the changes is required for the user service. Scalability. Scalability means just now we discussed. So if I want to increase this only order service, I can able to increase the only order service only. Okay, so that means so I can scale this database without considering this data user database, product service or inventory service. I am getting this, I have some load in the order service. That means initially it is running on the resources are the 4 GB RAM, something low configuration. Then if the load increases, I can increase only these specifications only, only this database specification only. Okay, I won't worry about the remaining three. Why? Because the load is normal to the remaining three, but load is increased in the auto service. I can able to increase this specific database. That is possible. Next one is the fault isolation. Isolation means, so if you suddenly if you face any failure in this database, it won't affect in the remaining things, it only affect in the respective service. Maybe, so now I have the issue in the this service. Okay, it is not responding. That means the user can able to log into the application and they can able to see the products, but the only thing is they cannot make the orders. Why? Because now I have the only issue with this one. So if you go with the normal monolithic application single database pattern, so once it is done, entire system will be goes down. Okay, but now here it is a fault tolerance. That means one database is goes down, the entire system will up only, there is no effect, less effect. Flexibility in database technology, that means we are able to choose the different type of the technologies, right, without worrying about the other service. Yes. Simpler schema management, services can manage their database schemas independently, making easier updates and deploy changes. That means if you want to change any table structure in any one of the database, you can simply change it. Why? Because it is running independently, it won't disturb any